In this video, I'm going to teach you about square roots and the Pythagorean theorem. Now, what is a square root? Say we have the number 3 squared. We know that 3 squared is 9. This base right here, 3, is the square root of 9. The square root symbol looks like this, almost like a check with a line. So if I was to say the square root of 9, we know that that is equal to 3. However, the square root of 9 can also be a negative 3, because negative 3 times negative 3 also gives you 9. So the square root is the number that is multiplied by itself to get your answer. As a formula, we can write x squared equals y, then positive and negative x is the square root of y. So if I give you x squared equals 16, we have to find out what this x is equal to. But we know that x squared equals some number, then x is the square root of y. So we just take the square root of 16. So now x equals the square root of 16. So what times what equals 16? Well, you can punch this into your calculator because there's a square root function on your calculator, or you can know that 4 times 4 is 16. So x is going to be equal to positive 4, and x is going to be equal to negative 4, because a negative times a negative is also a positive. Now, let's look at the Pythagorean theorem. The Pythagorean theorem is a formula used to find the length of a side on a right triangle. This is key. It can only be used for right triangles. The Pythagorean theorem is a squared plus b squared equals c squared. So given a triangle like this, it's a right triangle, so that means we're going to have one angle that's 90 degrees. Your A and B are the sides of the triangle that are touching the right angle. C is the length of the side that is directly across from the right angle. And this will always be true. Your hypotenuse C is always across from the right angle. Now, we know that addition is commutative, so this A and B can be switched, and it will not matter. The only thing that cannot switch is this C right here. So, let's look at a quick example. Say I give you a right triangle where one side is 3, one side is 4, and I ask you to find this side C. All we have to do is plug the 3 and 4 into our formula. So we're going to do 3 squared plus 4 squared equals c squared. Now we know that 3 squared is 9 and 4 squared is 16. So we're going to get that 9 plus 16 equals c squared. 9 and 16, we can add those together. So we're going to get that 25 equals c squared. But what I asked us to find is this c right here. We're looking for the length of this side. In the formula, the c is squared, So we have this squared right here that we need to somehow get rid of so that this can just be c. But remember that if x squared equals y, then x is the square root of that y. So c is the square root of 25. And the square root of 25 equals c. And the square root of 25 is a positive 5 or a negative 5. But we can rule out the negative 5 because you cannot have a negative length when dealing with a triangle. Therefore, our answer is that 5 equals c. So this c becomes a 5. Let's say I give you this triangle below. One side is 1 foot, another side is 2 foot. One side is 1 foot, another side is 2 feet, and we have to find c. So I'm asking you to find the length of this side c. Well, let's write down our formula. A squared plus b squared equals c squared. And then we're going to plug these numbers in. Let's say that 2 is going to be equal to a, and 1 is going to be equal to b. So we're going to have 2 squared plus 1 squared equals, we don't know what c is, so this remains c squared. 2 squared is 2 times 2, which is 4. 1 squared is just 1, and we're left with the c squared on this side. 4 plus 1 is 5, so we have that 5 equals c squared. But we're not done. We're looking for this c, so we need to get rid of this square with the c. And we know that c is the square root of 5, so we just take the square root of 5. The square root of 5 is going to be equal to c. So c equals, punch it into your calculator, you're going to get 2.24. So c is equal to 2.24 feet, because that was our label. Now if you notice, c is always going to be greater than a, and c is always greater than b. So c is always going to be your greatest number. So that's a good way to double check. And 2.24 is greater than 1 and greater than 2. Let's do one more example. Let's say I give you this triangle pictured. Let's look at this triangle. We're finding what x is equal to. So that's what we're going to solve for. So let's write down our Pythagorean theorem. Our Pythagorean theorem is a squared plus b squared equals c squared. Now remember, c is always directly across from this right angle. So now we know our c. Our c is 7. So we can go ahead and fill that in. 7 squared. X can either be our a or our b. So let's make it our a. We don't know what this x is. So this a squared will become an x squared, and we're trying to solve for this x. And we have our other side b, which is 3 squared. We don't know what x squared is, so we're going to leave that. X squared plus 3 squared is 3 times 3, which is 9, is equal to 7 squared, and 7 squared is 49. Now we're trying to solve for this x, so we're going to move this 9 to the other side and get rid of it. So we're going to subtract by 9, and whatever we do to one side, we have to do to the other side. So we're going to be left with x squared plus 0 equals 40. X squared plus 0 is just x squared, so x squared equals 40. This means that x is the square root of 40. and we're only looking for a positive number, so when we punch that into our calculator, we get that x is equal to 6.32 or 6 32/100. So this x is 6 32/100. Now remember what I said about the hypotenuse always being bigger than the sides. 7 is bigger than 6.3 and 7 is also bigger than 3. So this checks out.